Hello class, let's now have our lecture video discussion in Highway and Railroad Engineering. Study guide for module number 4 is entitled Geometric Design for Highways and Railways. Now for introduction, geometric design of highways. The design of highways necessitates the determination of specific design elements which include the number of lanes, lane width, median type, if any, and width, length of acceleration and deceleration lanes for on and off ramps, need for truck climbing lanes for steep grades, curve radii required for vehicle turning, and the alignment required to provide adequate stopping and passing sight distances. So this will later be discussed in a separate video along with some problem-solving exercises. Many of these design elements are influenced by the performance characteristics of vehicles. For example, vehicle acceleration and deceleration characteristics have a direct impact on the design of acceleration and deceleration lanes, the length needed to provide a safe and orderly flow of traffic, and the highway alignment needed to provide adequate passing and stopping sight distances. Furthermore, vehicle performance characteristics determine the need for truck climbing lanes on steep grades, where the poor performance of large trucks necessitates a separate lane, as well as the number of lanes required because the observed spacing between vehicles in traffic is directly related to vehicle performance characteristics. In addition, the physical dimensions of vehicles affect a number of design elements, such as the radii required for low-speed turning. So, imagine a 10-wheeler truck and you are to design a curve for turning. So, of course, you will need to consider the length of the trunk of the truck. Height of highway overpasses. So, imagine that if you design overpasses in highway, of course, you will consider what kind of vehicle to pass on that highway. So, if you have there a 10-wheeler truck, of course, you will put it higher. And lane widths. When one considers the diversity of vehicles' performance and physical dimensions, and the interaction of these characteristics with the many elements constituting highway design, it is clear that proper design is a complex procedure that requires numerous compromises. So you will sometimes expect that you will compromise something in the design of highways. For example, you might compromise some aesthetics or some social aspects or economical aspects of your design. It depends on whether which is more beneficial for the public. Moreover, it is important that design guidelines evolve over time in response to changes in vehicle performance and dimensions, and in response to evidence collected on the effectiveness of existing highway design practices, such as the relationship between crash rates and various roadway design characteristics. So imagine if the area is accident prone, of course you will reconsider the design of the highway. Current guidelines of highway design are presented in detail in a policy on geometric design of highways and streets, 6th edition, published by the American Association of State Highway and Transportation Officials, or AASHTO. Because of the sheer number of geometric elements involved in the highway design, a detailed discussion of each design element is beyond the scope of this module, and the reader is referred to AASHTO 2011 for a complete discussion of current design practices. Of course, we cannot cover all within this semester. Instead, this module focuses exclusively on the key elements of highway alignment, which are arguably the most important components of geometric design. As will be shown, the alignment topic is particularly well suited for demonstrating the effect of vehicle performance, specifically braking performance, and vehicle dimensions, such as driver's eye height, headlight height and tail light height in the design of highways. By concentrating on the specifics of the highway alignment problem, the reader will develop an understanding of the procedures and compromises inherent in the design of all highway-related geometric elements. So, this, as mentioned a while ago, the sight distances problems will be on a separate video, and we will be having some problem solving exercises there. So, as continuation for this discussion, we will go to the reference Max B. Fajardo. That will be on page 34, and we will start with road shoulder. So, one of the geometric design elements. So, road shoulder. So, what is road shoulder? Road shoulder or verge is defined as that portion of the roadway between the edge of the traffic lane and the edge of the ditch, gutter, curb, or side slope. ASTO requires that its usable pavement width shall be strong enough to support vehicles. Why? Of course, you will park your vehicle there, so you wouldn't want your vehicle to be crushing because of a poor design on the road shoulder. Importance of road shoulder. Road shoulder serves as a place for vehicles to stop when disabled or for some other purposes. Road shoulder considerably reduces road accidents. Why? Because it provides opportunity also for the vehicle to overtake a vehicle, or that when a driver is sleepy, of course you can just park on a road shoulder and take a nap for some time. The road capacity is decreased and accident opportunity increases if the shoulder is too narrow or omitted in the design. So take note of that. The road capacity is decreased and accident opportunity increases if the shoulder is too narrow or omitted in the design. So that's how important road shoulder is. Imagine the area if the road shoulder is too narrow, or that the road shoulder is being occupied by vendors. So there's not enough space for a vehicle to overtake, or there's no space for a vehicle to stop. Thus, accident could happen if road shoulder is too narrow or is not considered in the design. Shoulder should be continuous along the full length of the roadway. It also adds structural strength to the road pavement. Well, that is especially true. Imagine the road shoulder here, example here, or the road shoulder. If this is your roadway, this blue line here is the road pavement, and imagine if there's no road shoulder here, this portion here is being omitted. There. So only the road pavement is exposed here. So you will be expecting that it's like a cantilever, and your vehicle, especially if you're overtaking, this is the wheels of your vehicle. So not enough support, isn't it? There's a probability of having a failure in this area if there is no road shoulder to support your paved roadway. So it adds to the stability of the design of your highway. Next, number 4, shoulder increases the horizontal sight distance on curves. It reduces accident potential when vehicles stop during emergencies. Now, on curves, of course, having a shoulder, especially if this is your roadway, the blue line is your roadway, and you provided a road shoulder here on the green line. So, and this is some obstruction. So the passing vehicle has enough okay, so there is enough sight horizontal sight distance for this vehicle here if it is moving that way. Has enough sight distance with the shoulder provided versus with the omitted shoulder. So there is limited eyesight here, limited horizontal sight distance there. So that's also for safety reason. So road shoulder is not just for aesthetics, but it serves its purpose to reduce accidents. And how do you determine if an area of a paved roadway is the shoulder? Well, here is a clue given. A continuous narrow white line strip at the edge of the roadway separates the shoulder and serves as guide to drivers during bad weather and poor visibility condition. The white strips tend the driver to stay in the traffic lane, and the vehicle seldom infringe on the shoulder. Okay, so here are the policy on geometric design recommendation for shoulders. Outside shoulder should be paved for at least 3 or 3.6 meters wide if truck volume is more than 250 in the design hour or the average daily traffic. So if there is many trucks passing in your roadway, you will be providing at least 3 or 3.6 meters wide width of shoulder. And the recommended width of left median shoulder is 1.2 to 2.4 meters with at least 1.2 meters paved. If there are 6 or more lanes, the median shoulder should be 3 meters wide or 3.6 meters if truck volume in the design hour exceeds 250. So the more trucks that passes, the wider your road shoulder should be. Okay, so these are the policies on geometric design. Okay, so since there are many, we will not discuss them all. So here are the given plan, cross-sectional plan here when designing shoulder. Here are the detailed plan, and you can follow it when you design the highway too. So the part here is your roadway with S slope roadway, and then we have there the stop lane. Okay, so this is their stop lane, 2.5 meter or 2.25 or 2 meters with the inclination 5% or slope of 5%. Then another inclination of 7% here, and this comprises the road shoulder. The road shoulder 3.25 meters or 3.3 meters or 2.75 meters. And then beyond the shoulder, you will have your slope or ditch. So you can have gutters, concrete masonry or masonry. So you can provide that so that the water could be impounded in these areas. So what could be, or how does a shoulder look like? So we have here example of a road shoulder. So road shoulder here could be paved or unpaved. This picture shows an unpaved shoulder. So, but you can observe that it uses gravel and not clay. Imagine if it's clay soil that's being used here. When it's raining, the clay soil tend to be soft, so you cannot park your vehicle here or use this to overtake when the soil used for the shoulder is clay. So it is always advisable to use gravel so that it has more strength than the clay. We also have paved or cemented roadway, so this is much better. See, it helps also in maintenance of the roadway. So this is the white strip, the white line here that separates the roadway with the shoulder, and you can park your vehicle in the shoulder, you can overtake here, and also it helps to maintain the roadway, so there is no crack if there is a road shoulder here. Okay. Here are the kinds of road ditch. The road ditch could be concreted like that, or earth, non-concreted. So here are the road ditches, which we can often see here in the Philippines. Now this one is better. It has vegetation here, so there's less occurrence of soil erosion. So when it rains hard, then the slope of the ditch is maintained, and also the width of the canal here is maintained, rather than having this kind of ditch. Of course, you can expect that there will be more soil erosion there because of the lack of vegetation. But this is way better, but it will be more costly. So there you go, your consideration also for the economical aspect. Okay. In the road shoulders, you can also use parapet. So this is the parapet here. So what is a parapet? Like that. So you can have that at the end of the road shoulder. So this portion here is the much paler color of the concrete is the road shoulder. Actually, this is not yet finished, so that's why it is still under construction. So this portion here is the road shoulder, and the portion there is the roadway, and this is the parapet. Okay. How about barrier? Barrier is use also in the road shoulder. So barrier so it could be used. Also this one, any barrier, so that especially when there is body of water, you can use barriers. Okay. Now how about a guardrail? So we have here also guardrails. When we are considering the design guardrails here, we can have the stop lane 2.5 to 2.25 or 2 meters, and the overall road shoulder is 3.25, 3 meters or 2.75 meters. So a guardrail looks like this. So this is your guardrail, which you can commonly see when you're traveling. So this is included the length of the road shoulder. You include the guardrail. Okay, so this is very useful whenever we make design of highways. So this provides also the slope, the inclination, and the dimension, the distance from the travelway to the certain elements like footpath, parapet, guardrail, and barriers, even ditches. Okay. Now how about the cross slope? The cross slope is provided in all tangent sections of the roadway. Slope usually falls in both directions from the center line of the two-lane highway, except where super elevation of curves directs all water towards the inside. So what's the purpose of this? The slope, the cross slope, will help to remove the water from the roadway. So for high type pavement, the crown or slope is often 1 to 2%. However, steeper slopes are strongly recommended because rainwater flow away more rapidly, reducing the water thickness on the road pavement. A cross slope in one direction of multi-lane highways makes driving comfortable, but with heavy rainfall, the water depth increases on the roadway. So yes, this is how it should be. There should be slope so that when it rains, the water goes out of the travelway or the roadway. Now, as mentioned, for the curves, the slope, even though it's a two-lane curve, the slope should be on one direction to inside. When water hits the pavement, so when water hits the pavement, the flow of water should be towards the inside. Okay. So that's how you design for the curves. Okay, so 1 to 2%, but says there much steeper is much better. Now for cut or fill slope, the safer, says there, earth fill of normal height is safe on a slope of 1.2 ratios, meaning 1 for the horizontal and 2 for the vertical. So this kind of slope for a earth fill is much safer and could be observed. Now, how about the highway median? Recently, median in various forms becomes absolute requirement for highways because it offers the following advantages. It is an effective means of reducing headlight glares, conflicts, and accident between opposing streams of traffic. The median offers refuge between opposing traffic stream of cross traffic and pedestrian could traverse each stream at separate maneuvers. Median provides available space for left turn lanes. It makes turning of vehicles smooth and safe operation. Now, what does a median look like? So for a median, so it says here, the median strip or central reservation is the reserved area that separates opposing lanes of traffic on divided roadways such as divided highways. dual carriageways, freeways, and motorways. The term also applies to divided roadways other than highways, such as major streets in urban or suburban areas. So here are the types of medians that we can observe. Here, this part here, the unpaved area is your median. This one also is a median, the green part here. Also, this one has a barrier in between lanes, so it separates opposing lanes. Now, here are the designs for medians in different velocities. With the velocity of less than or equal to 100 km per hour, the median, so it says here, we have here a 3 meters median. Also, in a velocity here, when we have a paved median, so it's still 3 meters. For a velocity of 1.2 km per hour, we can have a 30 meters median. And some vegetation here is advisable also. Okay, so this is for greater than 80 km per hour. So we can have in the median, we can have brush curve here, parapet. So always remember, these are opposing lanes here. Opposing lanes, one goes to the left, one goes to the right, something like that. Then we have here barriers. Okay. Median approach. So as you can observe in our median approach here, the width of the median is decreasing. So we can have this kind of median. So this is a median approach. Okay, now for the next topic, the vertical curve over crest. The stopping sight distances, passing sight distances will be on a separate video.